Hello, good morning everyone. Am I audible to everyone?
Yes, sir.
Good morning, sir. Yes, audible.
Okay. Thank you. So in the last laboratory session, I haven't told you about the basics of Illusion software, and we tried to execute the experiment once using the Illusion software. Some part of experiment one was performed already. So today we will try to do the remaining part of the experiment one. So the experiment one is the visualization of single and multi-band images and their image statistics. So today we will do the histogram analysis of those images. So usually we select TMB1 to TMB3 images. So to assign the task for today, I am sharing my screen. I hope it is visible to the other side.
Yes, sir.
Yes, sir.
Okay, from the chapter 6, you can open the page number 219. If anybody is not having the chapter 6 file, I can share again. Chapter 6 file is shared in the meeting chat. Those who are unable to find can access that file from meeting chat. So when you open the page number 219, see the heading calculation of histogram. So read the instructions given in the table below and try to fill the table 6.3 for the TMB1, TMB2 and TMB3 images. And further, you need to answer all these questions for the TMB1, TMB2 and TMB3. So this is the task for today. You need to fill this table 6.3. And
hello, sir.
Yes.
Sir, there is a student whose name Shakti Jayasri. She not join. I don't know why, but maybe you do something so she become join us.
I think
Shakti Jayasri.
She is added to the team or not?
Sir, already she added.
But not joined.
Yes, sir, not join. She asked me to share the link, but I don't know how to do that. So, can you do that? So it's easy for us.
No, what is the issue?
Actually, sir, she messaged me. Is PRS class started? Then I say yeah. So provide me a link. I don't know why she not join us. So I think I don't know how to do that. So I'm asked to my teachers.
So you can share the link with her. There is no issue, and she's there in team. I think all the students are there in team.
Okay, sir. I don't know. I never do it before, sir. So can you assist me how to do that?
See, based on the latest detail which we have regarding the registered student in this branch,
Yes, sir.
their names are already there in the team.
Sir, I have Done, sir.
Okay.
Sir, I am
If
calling
she,
her. She will be.
Yeah, sir.
if she just recently registered in this course, then obviously we need to add her in the team. So ask her to send all the details, including her MS Teams ID.
Okay, sir.
Now
So
she is
she
there,
will
sir.
be added. Even you can share the link with her. She can join outside, from the outside, through her Gmail ID. Even she can join this.
Yes, sir.
Okay. Yeah, Mukesh, please continue.
Okay, thank you, sir. And for the three majors, TMB1, TMB2, and TMB3, you need to fill the table 6.3 and answer the few questions related to the histogram. It is given in the page 219 and 220. Okay, and try to fill these tables, and uh, I will again join at 11:30. Hello. Uh, I hope you tried to fill those tables, and now I will tell you the procedure to fill the table, and you you can simultaneously match the values in the table, and those tables can be kept for the lab record. For that, I am sharing my screen. First, you need to open the histogram of TMB1. Open the LS software and you will see the window like this, and you can navigate to the folder where you have the data. We are using the UG data 06 for this experiment. And then after navigating to the folder, you can click on the operation tree in the left pane and click on histogram. In the drop down menu, you can select the TM band, and among the TM bands, you can select the TMB1. Then click on show, you will get the histogram like this. Based on this histogram, we need to fill the table 6.3. In this table, it is saying DN values at a specific cumulative percentages. So you need to see the row with the cumulative percentages and then corresponding DN values. This is the row for the cumulative percentage, and select the DN values having the 0 cumulative percentage. So in that column, in the same row, you can find the value DN value. So for the DN value 24, or you can select from any pixels having 0 cumulative percentage. So the value may be 22, 23, 24 in the for the cumulative percentage 0. In the same manner, you can find the DN values for 0.5, 1, 2, 5, and 10. Suppose you want to find the DN values corresponding to the cumulative percentage 100, then you can get the value 127, 128, 129, 130 like this. Suppose you want to find the DN values corresponding to cumulative percentage of 90, So no specific value is found, then you can empty those DN values. It is asking for a specific cumulative percentage. If the value is not present, you can make it empty. Means no DN values will be filled if there is no DN value found to the corresponding cumulative percentages. Suppose we are getting the DN value with the cumulative percentage 0, then we can write here. And if there is no value present, no DN value present at a specific cumulative percentage, we can make it none. In the same way, you can open the another histogram of TMB2. And from this histogram, you can fill all these values with the specific cumulative percentage. This is the row for the DN values, the leftmost, and second last row is for the cumulative percentage. In the same way, you can open the TMB3 image. And you can try to fill those tables. To answer the questions related to histogram, suppose you want to answer what is the total number of pixels in the image. So this can be easily found in the histogram. The total number of pixels can be found from the npix row. And npix row, you can sum all these values and you will get some value, and you can write the answer of that question. After that, how many pixels have a digital number 68? Suppose we are at the TMB1 image and the 68. So the total number of pixels having the DN value 68 is the 2671. Then you can answer the question number 2 like this. Then how many pixels have a DN value more than 93? Then open the histogram, and it is asking for the DN values having the DN value more than 93. Then this is the value, DN value 93. After that, you can sum all these values to get the answer. 94 having 30, 95, 23, all these values will be summed together to get the DN values having value greater than 93. Next question, which DN represent the predominant value of the image? Means which DN value is highest in the number. So to find that value, you need to open the histogram and see in the npix row which value is the highest. So I think 43 value is the highest. 43 DN value is highest in the number. So you can write the 43 DN value is highest in the number. This is the most predominant value in the histogram for the TMB1 only. And in the same way, you can find this value for the TMB3. For the TMB3, the highest value is the 30. TMB3 is is having the highest number of DN values of 30. This DN value is dominant in the histogram. So this way you can answer all the questions for the TMB1, TMB2, and TMB3. And you can keep these tables and these answers for your lab record. And now I will tell you how to make the lab record. For the lab file writing, you can take a lab file as you used to write in the high school. So that same file can be used for the lab file record. In the right side, you can write the objective first heading and write the aim of the experiment. Then you can write the requirement for the experiment. Use software. Suppose you are using the LV software, and what kind of data you are using. You can write like images, satellite images, and what are the system requirements to run that software. You need second heading. In the third heading, you can write the brief theory about the image enhancement, LVs. Then you can write the steps to perform the experiment. And in the fifth heading, result section, this is the most important heading, and you need to write in your words what you have learned from the experiment. And it should not be copy and paste. Every student should have this own view on this experiment, on this result section. In the left side, you can make observation table diagrams, and you can take the print of the images you have used for the performing experiment 1, and you can paste on the left side of your left side of your lab file. And simultaneously, you can also make the Word file a soft copy for lab record, and it will be useful for the preparation of your lab exams when it will happen.
Sir, can we use A4 sheets?
No, you should make a lab record file like you have used in the high schools or intermediate. And A4 sheets, you can use A4 sheets to take the print of your Word file. Suppose you made the lab record in the soft copy, then for the submission purpose, you can take the print of that Word file. You need to maintain both the records because if there will be offline submission, then you can submit the lab record, and if there will be online submission, then you can use your soft copy.
Sir, means we have to make it on a soft copy, then whenever we need, we can have a printout of it.
But you can do this. You can do this. No issue. The result
Sir,
section must be different.
Sir, can we get that format which you were showing just now?
Okay, I will share that format.
Thank you.
And if you are getting any difficulty in performing this experiment 1, you can again ask your queries.
Sir, that summation part, we have to do it manually, or is there any way we can perform it directly on Elvis?
Repeat your question.
Sir, I'm saying for summation part, which we have to sum that number of pixels after 93, that in summation part we have to do it manually by our calculator or anything else, or we have any method which we can perform directly on Elvis software.
You can copy those values and paste in the Excel sheet, and or you can use calculator. Any method,
Okay.
you need to find the answer of that question. It will
What's
not directly come in those histogram.
Sir, I couldn't hear what just now you said.
You just need to sum all these values. It will not directly calculated in the histogram itself. You
Okay,
can
sir.
copy those values and paste it to the Excel sheet and make the sum, or you can use calculator
Okay, sir.
for that purpose.
Thank you, sir.
सर ये क्वेश्चन कहाँ दिए हैं?
In the chapter 6, you can see the questions on the page number 219. Chapter 6 has been shared in the lab, in the meeting chat.
Sir, it has 68 pages.
Okay, go to the page number 219. I am also sharing the manual for writing the lab record. And you can follow the instructions given in this file to write your lab record.
Sir, in diagram part, do we have to make the histogram diagram?
You need to paste the image and the corresponding histogram.
Okay, sir.
Not with the values, just histogram.
Okay, sir.
You can directly get the histogram of the image, like suppose you open the Elvis software, and in that you open the TMB1. And in the options, you can get the show histogram. So you can crop this histogram. Sorry for that.
Sir, that only histogram picture, not the values, no?
Yes, yes.
Okay, sir.
in the option show histogram, and you can crop using the snipping tool
Yes, sir.
in the Windows. You can directly get the histogram, just crop this part, or you can directly get it from image also. Suppose you open the TMB3 and in the show histogram, you can get the histogram.
Okay, sir.
And the analysis part must be used, and the other things may be same. Hello. In the remaining time, you can also perform the linear stretching operation. The steps are given in a very easy manner, and you can follow those steps and perform this linear stretching. Linear stretching is the operation of extending the range of DN values. Suppose our image is having the DN values ranging from 30 to 85, then these range can be enhanced for the image enhancement purpose, and the values can range from 0 to 255. And this is the concept of linear stretching, and you can follow these steps given in the chapter 6 file and perform the stretch operation and try to fill the table 6.4.
Hello, sir.
Yes.
Sir, can you explain the linear stretching in a simple word? Because you say the range is getting and something. I didn't get the thing. So
Okay.
explain.
No issue. Okay.
Sir, one question is there.
Yes, Yashowardhan Yadav. Okay.
No, sir.
There are three
I'm sorry.
faculties, and the lab course is only Geo-Informatics Lab 1. For three, there are three sections of this level 3. This for the PRS, you have to make a separate lab report file. In the Word format, you can make, and later on for the submission, you can take the print of that Word file and submit that. For all three faculties, you need to make 3 lab reports.
Okay, sir. Thank you.
Okay. To perform the linear stretch operation, you can go to the. Let me share my screen. Open the LV software. Navigate to the folder on which you are having the data. If you open the histogram of image from the operation tree, you can go to the histogram. If you open the histogram of TMB1, you will see the values are, most of the values are concentrated between 25 to 100. And the grayscale range is from 0 to 255. 0 for the darkest pixel and 255 for the brightest pixel. Okay. And if you want to make the linear stretch to enhance the image, for that purpose, you need to expand those values ranging from 25 to 100. You can stretch those values from 0 to 255. In this way, the image will be enhanced. Suppose you want to stretch an image, then you can go to the operation tree. Then image processing section, you can find the option stretch. In this window, stretch window, you can select the raster map for which you want to perform the linear stretch. Suppose I am selecting the TMB1 image, and we want to perform the linear stretching or operation. We can click on that, and it is already selected, and we can select the value range. It is already given 0 to 255, and click on show. Yes, we need to also make the file name output file for the stretched image. So the separate image will be generated. So you can make it as a stretch TMB1 stretch image. You can name the file as TMB stretch image, and it is TMB1. Click on show. Okay. And this is the stretched image, and the values are ranging from 0 to 255.
Hello, sir.
Yes.
Sir, can you compare the previous picture and the current picture so we can easily understood what the difference is there between them?
Okay, okay. You can open the TMB1 image beside that image. And you can see that stretched image is more refined. If it is not clearly visible in the screen, and you can open your I am sharing the stretched image, and you can open at your end to visualize the difference. In the legends, you can see the dark pixels has been reduced. In this, the darkest dark pixels are 28. In the stretched image, the dark pixels has been reduced, and the bright pixels has been enhanced. In this, we have only 80 brightest pixels. In this, we have brightest pixel in the number of 254.
So these
So-
all practicals are in practical number 1. That was first we show visualization, then comparing, then this stretching, then
Yes,
last
all
one.
this is a part of experiment 1.
So sir, how we have to write in first practical that we are performing the single first one practical, then we have to give different names to all the 3-1.
This is this all is the part of statistical analysis. Okay, the first
sir.
experiment is the visualization of single and multi-band images and image statistics. And this is the part of this histogram analysis, and you can write in this way. I will also share one sample file to you. On the basis of that file, you can write your lab report.
Okay, sir.
So when you are giving output file name, you have not given any file extension like .img or .tif. So this software took automatically this software took file extension, or we should give one?
Okay, okay. The file name will be a default, means no need to mention the extensions. The file name will be default as the source image. The image you will take and the transformed image will be the same.
Okay, sir.
If you want to separately change the extension, then you can mention the extension, and the way you do to change the JPG from PNG, etc. The same way you can also do that. These are the just images, and the format is MPR for these TMB1, TMB2, and TMB3. No need to mention that. In the same way, you can also perform the histogram equalization. This is another technique for the image enhancement. And suppose you can select the TMB1 and then histogram equalization. And you have selected the 256 intervals. Suppose there were only 100 intervals, and those intervals will be transformed to the 256 intervals. Means number of intervals will be increased, and you can name the name the output file as tmb1 histogram equalization. So in this way, the image has been enhanced by using the histogram equalization technique, and the output will be stored in the same folder on which you have the data. Here we can see the image and the corresponding histogram. Now you can see the histogram of the enhanced image. So the histogram image, this icons are, you can also see the icons. This each for the histogram icon will be like histogram, and for the raster image there will be a matrix, and for land use there will be different kind of icon will be used. For the coordinate system there will be another kind of icon is used, and for the map, so by just seeing the icon you can understand whether it is image or histogram or coordinate system or geo-reference image. You can identify just seeing the image icon. Just see the icon.
Excuse me, sir.
Yes.
Sir, there is an option just beside color composite slideshow one. Sir, what it shows us all the images one by one.
Suppose you open the image. Uh,
So just beside the color composite option, there is option slideshow. Sir, should I share my screen?
you can share your screen.
This one, sir. So what it's showing? Is it showing all the TM bands one by one?
Okay, let me check. Okay, let me share my screen.
Yes.
Suppose you try to open the raster map, okay, and you will get the image, this window. And in the slideshow option, there are 4 options: light, normal, dark, and gray. All these 4 options will be displayed in the slideshow mode.
Okay, sir.
Okay.
Sir, but which TM band is it showing? Because when we directly click it, it shows the random one. Which one is it? There particular or all the TM bands it is showing?
You can select the specific image from
Okay,
the options, and for that you can create the this slideshow.
okay, sir.
Hello, sir.
Yes.
So when I open a TMB1 image, so at the bottom 3 boxes, and one box is so latitude and longitude. So can you tell me what the rest of 2 boxes mean? Yes, sir. That one and first
This
and
one.
second. Yes, sir. Both.
Okay, this geo-referencing is a part of the second experiment. Okay, we will discuss in detail. in that experiment part. Okay.
Okay, sir.
Hello, hello, sir.
Yes, yes.
Sir, in table 6.4, I am getting only value corresponding to cumulative percentage of 100, and other values are for DN values are null.
Okay. It is for the specific values only. If you are not getting the specific cumulative percentage DN values, then you can make it empty or you can correct the cumulative percentage. If you want to mention the DN values corresponding to the cumulative percentage, either you can make it empty or you can correct the cumulative percentage.
Sir, how can I do that?
You can make your own table and cumulative percentage value. Suppose instead of 0.5 you are getting the cumulative percentage 0.61. You can mention those, that cumulative percentage and corresponding DN value. Are you getting that?
Okay, sir. I have to manually do that, or I have to copy that data to Excel file and then.
No, for the table, you just see the DN value manually.
Okay. Sir, can we do interpolation in that?
No interpolation required because each pixel is defined.
Okay, sir. Thank you, sir.
So,
Sir, we have to do this only for TM 1, 2, 3 or for all?
for this experiment purpose, you can it is required to do for only 3 images, TMB1, TMB2 and TMB3. Suppose you want to do for the another set of the images, then you need to mention that I have used these images, and
Okay, sir.
corresponding analysis will be done for that image only. Only 3
Okay, sir.
images are required, and you can take any one of them.
Okay, sir. Thank you, sir.
Hello, sir.
Yes. Yes.
Sir, I have a doubt in a statement which state that only the pixels value in the 1 to 99 percentile of interval will be used as input. So what does mean?
The meaning of that is to reduce the noise level. Okay. If you select the last pixel from the image, then there are chances of getting the noise in the image. So to reduce the noise, so the bright most and the dark most pixels are avoided. If you see the statement in the sketching,
Sir,
okay.
can you explain through the image so it's easy to visualize that?
Okay, okay. See here in the linear stretching section, after a histogram has been calculated for a certain image, the image can be stretched. And linear stretch is used here. Only the pixel values in 1 to 99% interval will be used as input. And the pixel values below 1% at the boundary and above 99% will be at the boundary. Suppose you apply a mask to the image, 3x3 mask at the image, then what you take for the boundary pixels. So there are chances of getting error at the boundary pixels. So we try to avoid the boundary pixels. Suppose suppose you are having this mask, okay? The values, this is the 3x3 mask, 1 to 1, 242 and 1 to 1. And you will apply this mask to the each pixel of the image. Okay, and the center value will be calculated. And everything will be fine, but if you get at the boundary pixel and your center pixel will be at the boundary pixel, then all other values are not defined. If you take the center of this mask at the boundary pixel, then for upper 3 values, you have not defined any value. And these will be some random values or maybe made 0, but the actual properties of the pixel will not be calculated. This is a part of image processing. This is a part of the image processing technique. If you have ever studied the image processing subject, then you can easily get that. Uh,
Sir,
Hello, what is your means BTech background? So in that context, I can tell you what is the meaning of boundary pixel.
Sir, my background is architecture.
Okay, okay.
excuse me, sir.
Yes, yes.
Sir, the PDF which you have given in that table, we have to make it on our file also?
Yes, the table need to make on your lab record file.
That should be in result part.
Pardon?
Sir, is that should be in result part or in somewhere else?
In the result section or observation section, you can write those tables.
Okay, sir. Sir, do we have to make a separate table for each thing that calculation part, that stretching for different stretching and for equalization? For all the three, we have to make a separate table.
Yes, for all three images, the three tables will be there.
Okay, sir.
And you need to mention that table in front of image name in the table.
Sir, what you said, I couldn't get it.
What?
So what you said in last, I could not get it.
Okay, okay. I said that you can write the name of the image above the table.
Okay, sir. Means image numbers.
Yes, TMB1 is the image, TMB2 is the image. Then you
Okay, sir.
you can write the table for the TMB1.
Okay, sir.
The meaning of taking only the input values from 1 to 99% is to avoid the boundary pixels, because boundary pixels create the noise in the image. If you try to enhance the boundary pixels, then it will be some spike values that will be resulted in noise. So we try to avoid the noise in the image. So we try to avoid the boundary pixels.
Sir,
Yes,
sir, when we make a lab file, then for how many images we perform that one?
3 images only.
Okay, sir.
TMB1, TMB2, and TMB3 generally we take, and you can choose among the 7 images TMB1 to TMB7.
So we make a hard copy. Then after that, we click a picture and just merge it and post on your upload that.
You need to make the Word file, and according to the file I have shared with the instructions, and in the result section you can paste the images and the
Okay, sir.
corresponding histogram, and table in the observations section you can make the table, and that Word file later on can be taken as a printout for the submission. If you are making a hard copy in the lab file, then in the left side you can paste the images and histogram. In the right side you can write the objective, requirements, theory, etc. Okay.
Yes, sir.
Okay.
Hello, sir.
Yes, yes.
Sir, can you tell me about minimum specification required for all softwares which are using in GIS? So, because sometimes we face difficulties to run QGIS and something. So,
Okay.
we have not. Yes, sir.
Okay. For all GIS software implementation, you should have at least 8 GB RAM and i3 processor.
And sir, what's about the graphics one?
If you will have graphics cards, because some of the software versions are needed for the graphics, so at least 1 GB graphics card is enough.
Thank you, sir.
Okay.
Excuse me, sir. Excuse me, sir.
बोलिए.
Sir, there's a question, which DN represents the predominant value most frequently occurring? Means we have to select the DN number which has the largest number of frequency.
Yes, you need to select the TN values which is highest in the number.
Okay, sir. Thank
So
you.
in the leftmost row, you are having the DN numbers ranging from 0 to 255.
Yes, sir.
Okay, in the value corresponding to which the n fixed value is the highest, that will be the
Okay, sir.
predominant value.
Okay, sir. Thank you.
Okay, I would like to discuss about the boundary pixels. One of the query of the student. So to explain that, I am sharing my screen. And you can see this is the image having the dimension and origin at the top left corner. And one 3x3 mask is used to enhance this image. And this mask will be moved all over the image to get the enhanced image. So this mask will be operated on each of the pixels of this image. Suppose this pixel, this mask is at the origin, then you will align the center pixel of this mask to the origin pixel. Then you can not get the values for the 5 pixel values, and you will get only the 4 pixel values, and all other 5 pixels can take some garbage value, and that will create the noise at the origin, noise at the boundary pixels. That's why those boundary pixels are not used for the image enhancement. To get a better quality of the image, we try to avoid the boundary pixels.
Thanks, sir.
Okay. I think there is some confusion regarding the objectives of the lab experiment. So I have already shared the file with you with the list of experiments. I need to share the laboratory file. Just open the laboratory syllabus. These are the 4 experiments for the Ilvis software. First experiment is visualization and image statistics of single band and multi-band images. Objective is this only.
Okay, sir. Thank you.
Welcome. Okay, thank you everyone for attending this lab. Now you can leave the meeting.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.